Welcome everybody to Percona Live Online 2021. So today's topic is joining heterogeneous databases is a reality, not a myth. So it's just a PostgreSQL foreign data wrapper. So my name is Ibrar Ahmed and have a welcome here. So who am I? My name is Ibrar Ahmed. I have been in software industry since 1998. I have started my PostgreSQL career since 2006 after joining Enterprise DB as an associate database architect, core database engine, and then now I have been with Percona since 2018 as a senior software architect, core database engine. I authored multiple books on PostgreSQL. And here is my Twitter account, my Facebook, my LinkedIn, and my personal website, pgelephant.com. I have divided this talk into 5 to 6 different topics. So subtopics actually. The first is the application architecture. Like if we want to connect to multiple databases, so what is right now our application architecture and what it should be. Second, what is the SQL met? What is a SQL to managing the external data? Then foreign data wrapper example, and then with some advanced topics about the pushdowns and connection pooling. And we have session of question answers. The timeline will be like this, that we will discuss the application architecture in 5 minutes, and then SQL met in 10 minutes, then 15 minutes of the foreign data wrapper example. Why I'm spending more time on example? Because in my opinion, example is the best way to learn something. Then we'll spend some time on DML, pushdown, and connection pooling. So the question is, if we have come across to the problem where we need to get the data, extract the data from different database engines and want to generate a result using that data, what can be the solution for this? Like, here is an example. We have a MySQL database, we have a PostgreSQL database, we have Hadoop, we have a MongoDB, we have Hive, we have a ClickHouse, and we have a simple disk of simple file system. So if we came across a problem where we want to connect to the MySQL database, and then also we need to extract some data from Hadoop, and based on that we need to extract some data from MongoDB, file from ClickHouse, from Hive. How we can do that? This is the problem, and this is in this talk we want to resolve this problem. So we will focus in that if on the problem, on a single problem where we want to connect to different heterogeneous databases and collect the data from there and generate a result. There are two ways. The one way is the easiest way, the oldest ways. Then we will learn a way the PostgreSQL provides. That's the topic we will learn today. So normally, how we will design our application. So everybody has its in mind that this application design look like this. Like we have our user application here sitting at the leftmost corner. Then we have to write some module to connect to the MySQL database. Like here we have written a MySQL module in our application, which will use libmysql client library to connect to the MySQL. So we have another module in our application, which is called PostgreSQL module, which will use libpq library to connect to the PostgreSQL. We have a MongoDB module, which is connect using libmongoc DB, and we have a JDBC module. We use JDBC to connect to Spark, Hadoop, and we have a JDBC another module which will use Hive. We will connect. You use JDBC to connect to Hive, and then we have ODBC module to ODBC to connect to the ClickHouse. Similarly, we have can have other module if we want to connect some other. It's a general architecture normally people use in their application. Like if they have two databases, they just have two modules of databases and connect to that databases, query their databases, extract the data from databases, and then join the data in the application and return the data to the application. So this is your application, which has different modules to connect to the database using respective database libraries, collect the data, and then join the data and generate the result. So how we solve that problem? That's a really rudimentary way of doing that. That if you have a 10 database, write 10 database module, connect each and every database, extract the data, join the data, and return the data. That's the normal way people are doing right now. Because there is another way. There is no other way. People can comment on that from MySQL, you can have a JDBC here. You can have a JDBC for MySQL too. But there are some other things, like if we have like here, if we have a file system here, which can only be accessed with using the file system API, and something like that, which does not support JDBC. So you have to write a different module for that. And you have to write a separate query. If you simply have a JDBC module for MySQL to have, but you need to write the query which MySQL language support, you have to write the query in a syntax that my MongoDB supports. That's mean even if you use a connection library, which is same connection libraries for all, like if you use here a JDBC for all of these databases, but in this module, you have to write the queries according to that database, because the simple select static from our relation table will not work with the MongoDB. So, because MongoDB has its own collections, so it has own syntax to query that. Similarly, PostgreSQL does not have all kind of a syntax that MySQL supports. MySQL does not have all syntax that my PostgreSQL supports. But somehow in relation databases, you can see some ANSI standard, ANSI SQL standard that they support something like that, but it's not 100% true that each database has the same syntax that other database has. So normally you have this kind of an architecture. So it's really difficult. The problem is really difficult because you have to learn MySQL, you have to learn PostgreSQL, you have to learn MongoDB, you have to learn Hadoop, ClickHouse, because you are writing queries according to their syntax. That means the DBA will only install these for you, configure it for you. For developer endpoint, you need to learn all of these databases and their style of queries, how to query them, how. So you have to learn this, and you have to write that kind of a query. So that's the problem. So we will come back to the same problem again after some slides. So SQL method. SQL for managing external data. So it's an extra SQL standard. It is defined by ISO IEC 905 //208. So SQL Met provides extensions to SQL that defines FDW foreign data wrapper. So SQL Met provides extension to SQL. It's an extension to SQL that defines foreign data wrapper. That means when a database need to provide its core implementation into their database, and then this foreign data wrapper can be written. So PostgreSQL start implementing in its core since PostgreSQL version 9.1. They gradually start building, adding the core machinery into the PostgreSQL, and now it's has almost most of the feature in it. PostgreSQL, for example, or you can say the for example, or for testing or for something like that, PostgreSQL itself also provide PostgreSQL FDW that use that machinery. That means why PostgreSQL FDW? Because if we are within the PostgreSQL, if we want to connect another PostgreSQL, then we require PostgreSQL FDW. So PostgreSQL provides this standard into its machinery. That does not mean that you automatically connect to all the databases. It's just a machinery. It's in PostgreSQL, and PostgreSQL only provides its machinery and after a PostgreSQL FDW. That means you can only connect to PostgreSQL within the another PostgreSQL. But now, after this machinery comes, people start writing foreign data wrapper for different databases. Now a bunch of the database has been covered. I have never seen, I think almost all the database has been covered, and people have foreign data wrapper written and available, freely available on internet. So here is the list of all the freely available foreign data wrapper, wiki PostgreSQL, wiki foreign data wrappers. You can get the list of there, you can get the link from there, you can download and use them. So after PostgreSQL foreign data wrapper, here is the architecture becomes. So here you can see your user application become very thin. 2 points has already been removed or moved. You can see that. The one, it's removed all the module from the application except PostgreSQL module. Now you have only PostgreSQL module in your application. You don't need to worry about MySQL module, MongoDB, Spark, Hive, ClickHouse, File. You don't have to worry about all the modules. And your developer don't need to learn MySQL syntax, MongoDB syntax, Spark, Hive, ClickHouse. You are writing, your application is writing query just in PostgreSQL syntax. So the application is free now of many things. An application does not need to join the data. Previously, if we go back to the previous slide, you see that we have a different module like MySQL, PostgreSQL, MongoDB, Spark, Hive, ClickHouse. Along with that, we are querying using this module and then joining the data into the application. Here we have only one module and we are not even joining the data here. So application is very thin. User application, PostgreSQL module, that's it. But here in PostgreSQL, we have increased some modules. And previously, PostgreSQL does not have that modules. Now we have installed MySQL FDW, PostgreSQL FDW, MongoDB FDW, STFS, File FDW. So we have installed a bunch of modules within the PostgreSQL. Now it's come from application to PostgreSQL. So now when you are writing a PostgreSQL query and you want to query MySQL, So in user application, you want to query MySQL to get the data. You need to write the query using PostgreSQL syntax. And from PostgreSQL client library, you are just connecting to the PostgreSQL client library here. Any PostgreSQL client library, libpq, ODBC, JDBC, but using PostgreSQL syntax. But you want to extract data from MySQL. So when you specify that you want to extract data from MySQL, then it comes to PostgreSQL, and PostgreSQL foreign data wrapper module give that data to MySQL FDW, and this module will convert PostgreSQL query into MySQL query, and using libmysql client library, get the data from MySQL, and then again convert the result of MySQL data into PostgreSQL format, and return back to the PostgreSQL. So we are writing the query in PostgreSQL, and we are getting the data in PostgreSQL format. Even the storage is MySQL. It's really simple. Somebody can say that MySQL and Postgres almost has same syntax. So let's have another example. You want to extract data from MongoDB collection. Here, you will write a PostgreSQL query in PostgreSQL syntax, right? Select static from table 1. Okay. And this table 1 is a table in PostgreSQL, but it is collection in MongoDB. So this query will be converted into MongoDB syntax and sent to the MongoDB using libmongoc library, and get the data in MongoDB format, and return the data, convert the data from MongoDB result to PostgreSQL result, and we will get our data as PostgreSQL syntax. That's the beauty of PostgreSQL foreign data wrapper. You don't need to learn the syntax of other databases. You don't need to parse the data into result into different databases. You will send PostgreSQL format, and you will get data in PostgreSQL format. Even if it's a live file, even it's a Hadoop, Spark, Mongo, any database, even it can be another PostgreSQL. Like in this application, you are connecting to this PostgreSQL, and you want to extract data from another PostgreSQL. Then it will just send the query to another PostgreSQL. You see that you were just getting the query from this PostgreSQL. Rest is done by the PostgreSQL FDW or other FDWs. So again, if we go back, you see here we have three things. User application is here, complete, join, and these are all modules in that application. But after that, you can see we have only one module, no join, and join is happening in PostgreSQL, and these modules are in PostgreSQL. So it's independent to application. Application don't need to worry about that. As I told you that example is really important thing, because I just told you what I told you. Maybe you missed something from here, but if I give you the example, it's really more clear than what I'm saying. So here we have United States stored in PostgreSQL locally. We have a local database, a PostgreSQL, which has a table named PG_TBL_stage. And just name it like, because in PG, so just I append it with PG. So we have some countries. So I just store continent and countries into MySQL. I have a two table here, MySQL table continent, MySQL table countries. So bulk data has been, I just stored in ClickHouse, which is ClickHouse table on time. So we have four tables. A PostgreSQL has a PG states MySQL has 2 tables, continent and countries. ClickHouse 1 table, which is on time. So we have a 4 table here in 3 different databases. So in PostgreSQL, we want to query these all 4 tables. So we need to set up it, because we need to tell PostgreSQL to which database contain which tables and what is their IP address, what is their username and password. Because if we want to connect to from PostgreSQL to MySQL, then that PostgreSQL must know what is the username or password of MySQL, what is the IP address MySQL password, what is the table name in MySQL. So here we are setting it up. We create an extension MySQL DB FDW. It's all depend that what is the name of extension. If you download a MySQL extension, then it's MySQL FDW. It's just a name. You just download it from internet. I just downloaded it from GitHub. Just go and download it from GitHub and check the name. If it's MySQL FDW, it's MySQL DB FDW. Just create extension. PGXN has almost most of the foreign data wrappers. So you just use PGXN. Most of the people already know what is PGXN. You use PGXN to install the foreign data wrappers. So just create extension. It will create the extension for you. Then you need to tell PostgreSQL what is the IP of MySQL server, on which port it is running. So here I'm just creating a server, create server, this server, MySQL server, and I just said that this server is related to this extension, MySQL DB FDW, and in option host is this. I can provide a remote IP address. I just provided here as a local IP address, 127.0.0.1 local host. And port is 3306. It can be any port on which MySQL is running. Right now, in this example, MySQL is running in my local machine. That's why I provided a local host here. If your MySQL is running in another computer, you can provide the IP address here. If it's running another IP port, you can provide the port. So I told you that PostgreSQL must know that what is the IP address of MySQL, what is the port of MySQL. It also required what is the username of MySQL and what is the password of MySQL. So here you create a user mapping, create user mapping for PostgreSQL server, and you provided this server. Option username is this and password this. Whenever we query MySQL server, it will connect to this IP address, this port using this user and this password. I will let you know how we'll do that. So now we have created an extension. That means we have installed the extension. We have created a server. We have provided the IP address and port. Then we create a user mapping where we provide the username password. Now we have to create a mapping for foreign table to the remote table, local table to foreign table. So create foreign table, MySQL table continents, and server this option DB name DB. That means we have created a virtual table. It's a virtual table because it does not store any data in it. On server, MySQL server option DB name DB. That means it will create a virtual table here, which actually reside on MySQL server database name DB. That means we already have MySQL. I told you that in previous slide, if you go back to the previous slide, we said that MySQL already have these tables, these 2 tables. MySQL already have this table, and this table already has data. PostgreSQL has this table, have data. ClickHouse this table and already have data. But here we are creating a virtual table in PostgreSQL which pointing to the MySQL server, MySQL table content table, and similar MySQL table countries. These table already exists in MySQL, but we are creating a virtual table which is pointing to the MySQL table. Similarly, we're doing the creating a extension ClickHouse DB FDW because we want to query ClickHouse. ClickHouse is a column store. You can just Google it and search what is ClickHouse, one of the best column store. So I just created a ClickHouse server and foreign data wrapper ClickHouse FDW. I just provided the foreign data wrapper name and just here I just provided a DB name test because every foreign data wrapper has its own option. So here option is database and driver. Option and driver. Because I just provided this driver and that name in this, and it can be have a multiple options too. So create user mapping for PostgreSQL, ClickHouse. So I just told you that previously the ClickHouse FDW, we are using the ODBC. So we provided ODBC and ODBC has its all configuration, but we need to provide a username and password. So we create user mapping for that ClickHouse server. Similarly, we did that with MySQL. Username ClickHouse user and password is ClickHouse password. Can be any username password. You need to have provide the proper username and password. I just give an example. So I just also created a virtual table which is already exist on ClickHouse. But here I just give a trick here. If we don't provide the table name, then this same table name should exist remotely. But these table name can be changeable. Like if you have different name here, and I just provided table name, a different name, XYZ, on time, something like that. So when I query this table, it will get data from this table. If I don't provide this, then exactly the same name will be used only remotely. So now the interesting part, here is the interesting part, that now we keep in mind that we are in PostgreSQL right from the start. So we have created MySQL FDW, ClickHouse FDW in PostgreSQL. Now within the same PostgreSQL, we are just querying from select static from MySQL table continent. From you can see the data. And this data is not stored in PostgreSQL. This data comes from MySQL. Because I told you this table is in MySQL. And MySQL contains that data. But here we write a query select static from MySQL table in PostgreSQL syntax. This is a PostgreSQL syntax. And PostgreSQL send that query, convert that query into MySQL syntax. Almost in this case, the query will be the same because MySQL or PostgreSQL query same in that case, but it can be a different one. Convert that in MySQL syntax, get the data from MySQL, and return the data in PostgreSQL format. It looks like it is coming from PostgreSQL, but it is coming from MySQL. Here, select code name continent code from MySQL countries. So I'm just getting this data from countries. Here from continents, from the countries, and this table is also in MySQL. It is not in PostgreSQL. PostgreSQL has just a virtual table in PostgreSQL, but actual data is in MySQL. So it is coming from MySQL. See, same table name exists in MySQL. So this data comes from MySQL database. but the syntax and the result both are PostgreSQL, but data is coming from MySQL. So another example, select country code, country name, continent name from MySQL continent, MySQL countries. I have just written some query which is joining two tables of MySQL within. But I am querying that using PostgreSQL syntax within the PostgreSQL and joining them and getting the result from MySQL. You can see the data is coming from MySQL, and this query is converted into MySQL syntax and that to MySQL, and that get the result from MySQL and displaying the results here. So country names come from MySQL countries. So select data from ClickHouse using ClickHouse foreign data wrapper. So who is querying MySQL using some simple queries like select study from continent, study from country. But from ClickHouse, I just write some complex query here. So select a.year and C1 by C2 as value from select year count static from this subquery inner join subquery on subquery. So I just write a complex query here. Why I am saying that it's complex? Because it has a select. This is a mathematical operation. It has from clause. It has a subselect. It has an inner join. It has another subselect. It has a group by. So it has many items, SQL items in one query. So I just write this query on a table, ClickHouse table on time. So interestingly, this data in ClickHouse, and this is the query of PostgreSQL. So in PostgreSQL complex syntax, we write a query in PostgreSQL syntax, and this query is converted into ClickHouse format and then sent to the ClickHouse and extract the data from ClickHouse and then converted the result into PostgreSQL format and then showing the result for you. So you don't have to worry what is the syntax of ClickHouse, how ClickHouse manipulate inner join, how from clause in ClickHouse, how where clause in ClickHouse, how subselects work in ClickHouse. You only worry about how these things work in PostgreSQL. You're writing the code in PostgreSQL, but it is getting the data from ClickHouse for you. And this is done by ClickHouse foreign data wrapper. So another interesting query here. Now I have table in PostgreSQL. I have two tables in MySQL and one in ClickHouse. And from PostgreSQL, I want to join all four columns and want to get the results. Here, select, here you can see that pg.code is a alias for the pg, PostgreSQL, name, country code, name, join, name, table, country code, country. Here you can see the one table is ClickHouse table on time, ClickHouse, and left join with table PG and left join with table MySQL. So here, when we are doing two left join with three tables and extract the data from three different heterogeneous databases. One is PostgreSQL, MySQL, and ClickHouse. So we are joining three databases data and getting the result in a one query. And the query is in PostgreSQL syntax and result is in PostgreSQL syntax. And underneath, this query converts in three different queries. One is for PostgreSQL, one for ClickHouse, and one for MySQL, and then it's join and give you the results. Here is the query. looks very complex, but it's not complex as it look like. I just explain that query, and you can see there are PG query is simple because PG query is internally consumed because it's the same PostgreSQL. But if you see that remote SQL for ClickHouse, select year origin name from default on time, and select code name from db.mysql table countries. So this syntax is being converted. This query is being converted in 3 different queries. One is consumed by PostgreSQL, and one is sent to the MySQL, and one is sent to the ClickHouse. And then this join happen, hash condition, and then hash right join has been happened, and you get the final result here. So third topic is actually the push down. It's a performance feature. What is the push down? Push down mean, like if we write a query in PostgreSQL and write a where clause there, if this where clause does not push to the MySQL end and resolve in PostgreSQL, then it's not pushing. If we push the where clause to the remote side, then it's called pushdown. You can say the predicate call pushdown. So we have operator and function pushdown. Like if we resolve the function locally, then we are not pushing down. If we send the function to resolve that function remotely or operator remotely, then it's called operator or function pushdown. Similar with predicate, similar with aggregate, similar with join pushdown. So we'll see some of the example here. Here, join pushdown, explain verbose, select, right join, PostgreSQL, join, JS, and you can see here the remote SQL. The important is the remote SQL, because in remote SQL, you can see it is pushed down or not, because this remote SQL is sending to the remote machine. And you can see the left join is happening, is sending to the remote machine. That means remote push down is happening. That means this foreign data wrapper, which is actually a PostgreSQL foreign data wrapper, support join push down. So what is the aggregate push down? As I told you that just explain verbose select count stack. It is aggregate from PostgreSQL table name. So if you see remote SQL, you can see select count static from this same query has been pushed to the remote machine. And this aggregate is again sent to the remote machine. That means aggregate push down is working because it's a PostgreSQL foreign data wrapper. Suppose MySQL foreign data wrapper does not support aggregate push down. So what will happen? You can see the query select count static from MySQL table continent. You can see query select null from DB this. Wow. In this case, the aggregate is not pushing to the remote machine. It is querying all the values, all the nulls from the, like if it has 1 billion rows, that means select nulls. That means it is collecting 1 billion nulls from remote machine, and then it is just counting that, applying count on that 1 billion runs and returning just value which is a 1 billion. Or you can say if MySQL continent has 10 rows, it will select 10 nulls from continents and then just apply count static here, which is become 10 and then return with be 10. But in this case, it will return only 10 from remote machine to here. So data traveling is only 10. Here, if the rows are 10, then 10 nulls. If 1 billion rows, then 1 billion nulls will return and then will be counted here. So this is aggregate pushdown, which is advanced feature of that. Most foreign data wrapper supports aggregate pushdown now. So now another thing that that if where class, where ID is equal to 10. It is also pushdown. It's almost available on where you can say the call is also available in all the foreign data wrappers. So now we are coming to the connection pooling. What is connection pooling? Actually, most of the foreign data wrappers supports that. That's why I want to include that in my presentation, that when a client connect to the PostgreSQL and PostgreSQL convert the query into MySQL query, send the MySQL foreign data wrapper, MySQL foreign data wrapper connect to the MySQL query sent to the MySQL, and then result comes to the MySQL FDW, and then disconnected and result converted to PostgreSQL tuple and result. You can see the 1, 2, 3, 4, 5, 6, 7, 8. You can see 5, 6, 6, and 3 is happening every time. And this can be avoided. We are connecting to MySQL on every query, and we are disconnecting from MySQL on every query. If we are doing that query on every 1 second, every 2 seconds, every 5 seconds, we're continuously doing from query from MySQL. So we are connecting and disconnecting from MySQL. This is a bad, because we can retain that connection. How will we can do that? Here's the example. Example is just PostgreSQL query and then MySQL query here, and then find connection. There is a connection pooler here. If there is a connection pooler implemented in MySQL FDW, then it will use a connection pooler, find the connection. If connection available, it will use that connection. Otherwise, connect and add that connection into the pooler, and then query, result, and final result. So if it will pool that connection, if you first time you connect and query, that it will connect and query from MySQL and will not disconnect from MySQL. If you again query, it will find that same connection to the same MySQL server, it will use the same connection. It will not try to connect again with that. So that's the connection pooling. It's a performance feature, because you are not connecting, disconnecting, connecting, disconnecting with MySQL. It's not just for MySQL. It's just MySQL is an example. It's any foreign database. It can be a PostgreSQL FDW. It can be ClickHouse FDW. It can be MongoDB FDW. It can be any FDW. So actually, it's I think it's built over because people are working on that, and that some other foreign data wrapper is also start supporting the DML. And what is DML? It's data manipulation that you can insert, delete, update. Because since the first slide, I'm just discussing that we are selecting data from the remote machines. Now, PostgreSQL has support that you can insert data from PostgreSQL to MySQL in PostgreSQL syntax. You have the ability to insert the data to MongoDB using PostgreSQL syntax into MongoDB, and MongoDB foreign data wrapper automatically converts the data into MongoDB syntax and insert that. You don't need to worry about that. You can delete data from MongoDB. You can update data from MongoDB. So DML is also supported. Here is some example that supports DML. Not all foreign data wrappers support DML. Like HDFS does not support the DML. It's only support the Slack. So it's all depend upon the implementation of the foreign data wrapper that supports or not. So I think it's all about. I'm ready to have your question, your feedbacks, and everything. So thanks everybody.